In this second video on continuous time Markov chains under stochastic processes, we're looking at transition rate matrix. Transition rate matrix. So straight up, a transition rate matrix, which is also called a generator matrix, which you saw in the last video already as Q. So a transition rate matrix Q is used in continuous time Markov chains. It describes how fast transitions occur between states. And we also discovered there that every row of a transition rate matrix or uh, the generator matrix, every row goes to adds up to zero. So by definition, a matrix Q, which is equal to Qij, is a transition rate matrix if off diagonal entries are non-negative, off diagonal matrix that is Q11, Q1, Q22, Q33, they are non-negative. So all the Qij's greater than or equal to zero, and for I not equal to J. All right, for all the off diagonal, okay, off diagonal entries are non-negative, yeah. Off diagonal entries non-negative, then rows and sum. That off diagonal matrix entries are non-negative. So if anything is going to be negative, it will be things on the diagonal. That's all this is saying. Then rows sum to zero. That's what I just talked about previously. So summation of Qij's is equal to zero over J's, over the rows now. Then diagonal entries. The diagonal entries Qi's can be said to be minus summation of all the Qij's for J not equal to 1. Equal to I rather. Okay. Yeah, I think I didn't quite define this clearly in the last video. Thankfully, we have this now. So Qii is minus summation for Q not equal to I, Qij's like that. All the summation of every other thing. So the interpretation is that Qij is the rate of transition from state I to state J, while minus Qii is the total rate of leaving state I. So if you add up uh every other value, you get the total rate of leaving state I, and that's basically minus Qii, right? So then we talk about transition probability matrix, which we also saw the other time. So the transition probability matrix at time t is given as P of t equals e raised power qt, and this is called the matrix exponential, right? So in example one, for instance, if we have a two-stage system where we have state transition, so for transition from state 0 to state 1 is at rate 2. So from 0 to 1, that happens at rate 2. So this is state 0, this is state 1, 0, 1. So from 0 to 1, that's 2. And from state 1 to state 0, that is 3. So staying at state 0 is minus 2, staying at state 1 is minus 3. That's what this implies. And then we can then compute the probability transition probability matrix PT, which is e raised by q of t, which we can use the linear algebra linear algebra module under SciPy here, and we use exponential form. So this happens after 2. So if you want to see, you can already see a pattern of behavior here that this is like 0 0.6, 0 0.4. So if you go like several steps from here, it's possible you're going to get 0 0.6, 0 0.4, as equilibrium. That's like when you do pi q equals 0, you're likely going to get 0 0.6 and 0 0.4. That's what these ones are behaving like. Yeah, you can see that. So if you want to be sure, even time 100, it's still the same thing. So that means if you do pi q equals 0, you are going to likely get 0 0.6, 0 0.4 like that. Okay. So we have this like this. Then the interpretation of P of t now. This tells us that Pij of t, that's the probability of being in state J at time t. Okay, so the rows of PT sum to 1 as usual. So that's why 0 0.6 plus 0, 0 0.602 blah blah with all this will sum to 1 each. So, and rows of P of t sum to 1. Okay, that's what I just said. And then we talk about the holding time. The holding time is the time spent in state I. So the time spent in state I rather follows an exponential distribution, that is Ti follows exponential distribution with minus Qii. So the mean holding time is then taken as expectation of T sub I equals 1 over minus Qii, right? That's minus Qii. So for a particular state. So it means here that the probability of staying in state 0 will be 1 over minus Q00. That's 1 over minus 2, which is 1 over 2. That's 0 0.5. But this one to be 1 over minus 3. That's 1 over 3, like that. That's the holding time. That's the time spent in state I. like that. Then we come to jump probabilities, which we also saw in the last video. So when leaving state, the probability of moving to state J is Pij, which is Qij all over minus Qii, right? So if you have P01, so that means that you have Q01 over minus Q11, like that. So so when leaving state, the probability of moving to state J. So it means if you follow this example now, look at it. So the generator matrix is minus 4, 1, 3, 2, minus 5, 3, 1, 1, minus 2. First, you want to confirm that it is actually befitting of a generator matrix, because if you add up each row, it should go to 0. Minus 4, 1, minus 4 plus 1 plus 3, 0. 2 minus 5 plus 3, 0. 1 plus 1 minus 2, 0 also. So total rate now. So if you compute the total rate, that is 4. And then the jump probabilities now. So for the jump probabilities for P12, for instance, probability of moving from state, so if you have 3, that means this is state 1, 2, 3, because sometimes you can do state 0, 1, 2. The probability of moving from state 1 to 2, the probability of moving from state 1 to 2 is actually, so you have P12, right? P12. So for P12 now, you then have for P12, that means you have Qij, that is Q12. Q12 is 1, and then all over minus Qii. So since this is from state 1, that is minus Q11. Okay, so you have Q12 over minus Q11. Minus Q11 is minus 4, so minus 4, that's 1 over 4. For P13, now moving from 1 to 3 here, okay? Moving from state 1 to state 3, right? So that means Q13, which is 3, all over probability, all over minus Q11, which is still minus 4. So that's minus 4, that's 3 over 4 right there. So for state 1, the total rate is minus 4, okay? From state 2, the total rate is 4 rather, that's minus 4. For state 2, the total rate will be minus 5, like this, minus 5, okay? And for state 3, that's minus 2, which is 2. Then we talk about the Kolmogorov forward equation. The evolution of probabilities is given by the P of T dt equals P of T Q. So the forward equation, we have P of T multiplied by Q. Or for the backward equation, you have Q multiplied by P. You have Q PT, P of T. But forward P of T Q. Okay? So with initial condition P of 0 equals I, the identity matrix corresponding with whatever degree the generator matrix may be. Then we have the stationary distribution. So a stationary distribution, pi satisfies pi q equals 0, and summation of all pi's, pi 1 over I is equal to 1, like that. So you have an example right here. So you have q minus 2 to 1 minus 1. So pi q is 0. So of course, if you solve this, I think we did it in the last video, and we got for the first pi, that's 1 over 3. For the second pi, that's 2 over 3. So when we get to the practice problems, I'm also going to do an example like this. So if you use Python code, you get that 0.333, which is 1 over 3, and 0.667, which is 2 over 3 there. And they're talking about the simulation of a continuous time Markov chain. So the steps, you have the sample holding time, which is exponentially distributed with parameter minus Qii. And then you choose the next state using Pij, which is Qij over minus Qii. So then you then import, so you import this whole thing now. So import numpy, then you have the matrix, the state is 0, t0, and all that. So if you run all that, now you get different states. So as you keep changing, the states keep changing. So at time 0.07, the state is 1. At 0.26, the state is 0. So it just keeps alternating between 0 and 1, because we have 2 states. So, and as you keep running, you can have different things showing, and that shows the different possibility in change of states. And with this, now we come to the summary. We see that Q contains transition rates, and each row sums to 0, like we've said, and the diagonal entries are negative. Then the non-diagonal entries are positive for sure. Then P of T is e raised by QT, which gives probabilities, and the holding times are exponential, and we already have a formula for calculating such holding times. Then, of course, we now comes to practice problems, where I may be able to solve 1 or 2 problems like that. So solve the following problems using Q as the transition rate matrix. So these are questions 1 and 2 now. So we want to verify Q is valid. Of course, to verify Q is valid, you have minus 3, 3, right? That's 0, 2 minus 2, 0. So it's a valid transition matrix. Find jump probabilities. That's where you do Qij over minus lambda I or something like that. Over lambda, lambda I. So then compute mean holdings. So then here, find all jump probabilities Pij. All jump probabilities Pij. No, Pij here is each Qij, all right? Qij all over minus Qii. So for if you take it as 1, 2, 3, 1, 2, 3. So to move from 1 to 2 now, that will simply be 2 over 5, Then for this to be 3 over 5. Then for this now, if you want to do moving from 2 to 1, that'll be 1 over 4. And then moving from 1 to 3, that'll be 3 over 4. Then for this other one now, probability of moving from 3 to 1, that'll be 2 over 3, because that's Qij over minus Qii. And this is Qii here. And for this other one, that'll be 1 over 4, so that, you have that going that way. So given Q is minus 2 to 4 minus 1, so compute P1, that means e raised power Q. All right. So we can easily do that using a code, right? Like that. Then we have, okay, let me even see if this what is it called now? If Desmos can do it, let's say, just want to try, who knows, it might just be able to do it because that's matrix exponential, right? So we have e raised to power, okay, e raised to power. How can I declare matrix here? No, I don't know. You have 2, 5. Okay, that's not working. That's not working. Okay, no worries. Let's just keep going. So find all holding times. So holding times has a very simple formula. Yeah, that's 1 over minus Qii. Okay. So to find all holding times in that case, now you just 1 over minus Qii. So to find all holding times, that's for state 1, that's 1 over minus 7, that's 1 over 7. For state 2, that's 1 over minus 6, that's 1 over 6. For state 3, 1 over minus 6, that's 1 over 3. Those are the holding times. Show that rows of any transition rate matrix must sum to 0. Of course, if you sum it up like that, you should get 0. So given this, now you have 4 minus 4, 1, 3, 2 minus 5, 3, 1, 1 minus 2. So you want to find the stationary distribution Q. Of course, that's the idea of saying you have you have pi times Q. So here to be 3 pi's equals 0, 0, 0. So if I don't have any other question, I'll come back to do that. So prove that Qii should be less than 0, that they are always negative. Of course, that's what we've been seeing. So given this now, compute jump probabilities from state 2. So jump probabilities from state 2 now. So if this is state 1, 2, and 3, so jump probability from state 2 to, say, state 1 will be 3 over minus Qii. That's 3 over 7. Then from another one, that's from state 2 to state 3, that'll be 4 over 7, like that. Find p sub 0 and explain its meaning. Okay, that's the initial time before you even start out. Given Q to be this, find stationary distribution. That's the kind of thing we did before. Explain why holding times are exponentially distributed. Okay, then given this, find mean time in each state. Okay, you want to find mean time in each state. Of course, that's the expected time or something like that. So that's 1 over 3, 1 over 4, 1 over 2. Then 13, 14, 15 now. Compute P of 0.5 numerically using Python. So this will be Q times 0.5, like that. The e raised power, all that. Then show that P of T will sum to 1. Of course, that always happens. So given this now, find total rate leaving each state. Total rate leaving each state. So you just compute. So from state 1 to 2, that'll be 3 over 8 and so on and so forth. So given Q to be this, find probability of jumping from state 3 to 1. From state 3, to state 1, that'll be 4 over 5 for sure, right? Because that'll be Q1, Q31 all over minus Q33. Like that. That's 4 over 5. Explain difference between P and Q. P is the probability transition transition probability function, or probability transition probability matrix, and Q is the generator matrix. So every row in Q adds to 0, sums to 0. Every row in P sums to 1, and all that. So given Q to be this now, verify it is a valid generator matrix. Of course, just add up and make sure it's 0. Minus 10 plus 4 plus 6, 0. 3 minus 8 plus 5, 0. 2 plus 3 minus 5, 0 also. Simulate a CTMC part for this, so you can use Python code. Explain why PT is U raised by QT is required instead of Q raised to power T. Aha, so we saw all of that before. So like I said before, if I don't see anything solid, I'll come back to do this. So we want to do we want to find the stationary distribution pi for this. So for discrete situations, right, we had to do pi p equals pi, but in this case we do pi q equals 0 because this is continuous here. So a bit nuanced like that. So to find the stationary distribution, find the stationary distribution pi, we know the formula is that pi q is equal to 0. So that means that pi, so for this is a 3 by 3 matrix, right? So pi has to be 1 by 3. So that means that we have pi 1, pi 2, pi 3, a row vector into Q, that's minus 413, that's minus 413, then 2 minus 5, 3, minus 4, 1, 3, 2 minus 5, 3, and of course 1, 1 minus 2, 1, 1 minus 2. All of this now should be 0, 0, 0, like this. So, and from experience, once you pick, anyone you pick will help you answer okay, maybe this may not happen here. Let's see how that goes. So in this case now, because you have just one row here, so you have minus 4, 2, 1, all right, okay, then minus 4 to 1, right? 1 minus 5, 1, 3, 3 minus 2, and then you have pi 1, pi 2, and pi 3. Then this is pi 1, pi 2, and pi 3. This is pi 1, pi 2, and pi 3, like this. And this is equal to 0, 0, 0. So then this is minus 4 pi 1 plus 2 pi 2 plus pi 3. Then this is pi 1 minus 5 pi 2 plus pi 3. And lastly, this is 3 pi 1 plus 3 pi 2 minus 2 pi 3 minus 2 pi 3 is equal to 0, 0, 0. So here you can then say that minus 4 pi 1 plus 2 pi 2 plus pi 3 is equal to 0. So we can actually say this is, if you like, this is 2 pi 2 plus pi 3 equals 4 pi 1, like this. So 4 pi 1 is equal to all that. So that means 4 pi 1 is equal to 2 pi 2 plus pi 3. So we have this. So we have that first. Then next, we can say we have another one. That's pi 1 minus 5 pi 2 plus pi 3 is equal to 0. So that means in this case now, pi 1 plus pi 3. Okay, well, I mean, since we're already on this journey, right? So that means that pi 1 is equal to uh pi 1 is equal to 5 pi 2 minus pi 3. Okay, so we have this one also like this. Yeah, because pi 1 is already subject to formula here. Then we can go for the third one, where yeah, this is good. Then we can go to the third one, where we can now say that 3 pi 1 plus 3 pi 2 plus 2 pi minus 2 pi 3, right? 3 pi 1 plus 3 pi 2, plus 3 pi 2 minus 2 pi 3 minus 2 pi 3 is equal to 0. So that now we can also have, you know, 2. So, okay, we can also say 3 pi 1. 3 pi 1, right, is equal to, or here, I don't know. Let me just, I can pick any two simultaneously. So we just have 3 pi 1 equals 2 pi 3 minus 3 pi 2. Okay, so we have this now. So if this is equation 1, this is 2, and this is 3. Okay, so we can then solve simultaneously. So I know that if we, so we can eliminate. Okay, let's do it this way. Let me do it this way. Let's make pi 1 the subject in each case. So this is 3 pi 1 equals 3 equals 2 pi 3, 2, or better still, pi 2 is always coming first. So let me just make it minus 3 pi 2 plus 2 pi 3, like this. And that is equation 3. So recall that pi 1 plus pi 2 plus pi 3 is equal to 1. Okay, it is equal to 1, not 0. So pi 1 is equal to 1 minus pi 2 minus pi 3. This is a very crucial expression here. So we can then go back to, so from equation 1 now, from 1, from 1, we have that 4 pi 1, 4 pi 1 is equal to 4 pi 1 is equal to 2 pi 2 plus pi 3. 2 pi 2 plus pi 3. So that is 4 into 1 minus pi 2 minus pi 3 equals 2 pi 2 plus pi 3. Okay, so this is 4 minus 4 pi 2 minus 4 pi 3 is equal to 2 pi 2 plus pi 3. So that this is now, we can tidy things up here, and we have 4 to be 2 pi 2 plus 4 pi 2 on one hand plus pi 3 plus 4 pi 3. So that this is 4 now to be 6 pi 2 plus 5 pi 3. So we have this kept for future future handling. So from 2 now, from 2, I can then have pi, from 2 pi 1 equals 5 pi 2 minus pi 3. From 2, pi 1 is equal to 5 pi 2 minus pi 3. So 5 pi 2 minus pi 3. Again, pi 1 is 1 minus pi 2 minus pi 3. And that is 5 pi 2 minus pi 3. Okay, so that we then have 1 to be 5 pi 2, 5 pi 2 plus pi 2 on one hand, minus pi 3 plus pi 3 on another hand, right? Yeah, so this cancels out very easily, I believe. And so 1 is equal to 6 pi 2. Okay, and things begin to factor out easily. So 6 pi 2 is 1 over 6, well taken. And then we can then get pi 3 from this now. So if we had called this, maybe we should have labeled this equation 4, and then this is 5. So we call this equation 5. So this is equation 5. So from 5 now, so from equation 5, where we then have 4 is 6 pi 2 plus 5 pi 3. 4 is 6 pi 2 plus 5 pi 3. Okay, 6 pi 2 plus 5 pi 3. So, and pi 2 is 1 over 6 from here. So 4 is 6 into 1 over 6 plus 5 pi 3. So this cancels this. So 4 is equal to 1 plus 5 pi 3. So we then have 4 minus 1 equals 5 pi 3. Okay, so this is 3 equals 5 pi 3. So by we divide through by 5. That's 3 over 5 is equal to pi over 3. Okay, so pi over 3 is 3 over 5 now. I mean, pi 3 rather is 3 over 5. So pi 1, which is 1 minus pi 1 minus pi 2, will then have to be 1 minus pi 2 minus pi 3. So that's pi 1 equals 1 over 1 minus pi 2 is 1 over 6. Pi 3 is 3 over 5, like that. So that pi 2 now is equal to pi 1 rather is equal to LCM is 30. So 1 is 30, that's 30 minus 6 and 30, that's 5 minus 5 and 30, that is 6 times 3, 18. Okay. This is fine. 30 minus 5 is 25. 25 minus 7 minus 18 is 7. Okay. Oh, nothing is wrong. Sorry, nothing is wrong. Everything is fine. Everything is fine. So pi 1, pi 2, pi 3 is equal to 1 over 6, 3 over 5, and 7 over 30. So in essence, this is like 5 over 30 plus 18 over 30 plus 7 over 30. So everything adds up to 1. So that's what we get there. That's a long one, but I mean, um, that's how we get, that's how it goes. If you add up this one now, everything goes to 1. So yeah, that's what we have. So with this, we come to the end of this interesting video. Let me know how helpful it is for you. Don't forget to try your hands on the questions. I've given clues to many of them. I solved one. You want to see how all the other ones go. So try your hands. Let me know how helpful it is for you. If there's something else you'd like me to try out, feel very free to let me know. If you have subscribed already, I thank you very much. If you haven't subscribed, why not go ahead and hit the subscribe and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you can also click on join to become a member of the channel. Um, that gives you some special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.